Titan, Saturn's moon, has an unending winter, with its temperatures ranging from -30 to 150 degrees. In those conditions, a human would expire, but a silicone-based life could live. This is the most common element in the Earth's crust. We know that carbon is a necessary component of life on our planet. Similarly, silicone can create bonds with 4 other atoms at the same time, producing complex molecules that are required for all kinds of life. Nonetheless, silicone bonds are weak on Earth due to the hot environment. However, they may feel right at home on Titan. The local frigid temperature will improve the stability of organic silicone matter to the point where all organisms with such body chemistry will be extremely slow in all aspects of life. If a silicone-based humanoid race has arrived on Titan, our astronauts will be disappointed if they want to shake their leader's hand. And heroic linguists from a rival would have to keep that sign up for days on end until the aliens could read at least one word. As a result, silicone-based humanoids will most likely locate some super-fast superheroes for humanity. However, the striking differences do not end there. Silicone-based creatures will not excrete carbon dioxide like we do if they breathe in oxygen. Instead, they will expel sand. I'm sure you won't want to welcome them to your tidy, comfortable Titan home. But how prevalent is this icy life in the universe? Silicone-based life can thrive on many more planets than humans, possibly billions. Keep in mind that most planets and moons in our solar system are cooler than Earth. These scientists have even been labeled as carbon chauvinists, although they have not yet been canceled, and their silicone chemistry looks unattainable to them. They will be astounded by the following alleged monsters. What if some types of life don't require chemistry? At a distance of 400 light-years, RxJ 1856.5-3754 is the nearest neutron star to Earth. It has a radius of only 14 kilometers, but has the same mass as our Sun. Its contents are so compressed that conventional atoms have torn apart, leaving just neutrons behind. And although neutron stars are 1,000 times fewer than conventional stars, I doubt that neutron creatures would believe we are genuine. Furthermore, their population would be much larger than that of carbon-based organisms. There must be hundreds of millions of them in the Milky Way alone. We cannot monitor most of these bodies simultaneously, except for very chilly planets and highly dense stars. Earth-like planets continue to exist in our Milky Way galaxy. They're not all that common. However, some astronomers believe that they may be home to carbon-based organisms that are comparable to us. On the other hand, this could be a complete and utter lie. What might life be like on an Earth-like twin? Consider the exoplanet Kepler-452b, which is about 1,400 light-years away from Earth. That is a considerable distance. Despite their attempts, scientists were able to notice one thing. This rocky planet orbits its star in a habitable zone. Kepler-452b has already been nicknamed Earth 2.0 because of its similarity to our planet. However, if scientists can find signs of carbon-based life on that planet using new generation telescopes, they may find a different kind of sterility. This characteristic allows organic molecules to have similar makeup and structure but have opposing appearances, similar to your right and left hands. Researchers came across a creature whose sterility deviates from the norms. As a biological organism, it would be undetectable by any earthly apparatus. Right-handed organic compounds in the human body would be left-handed in that species, and vice versa. This means that every sensor ever built on Earth is useless. Even on our planet, certain animals take advantage of the contending sterility because the entire ruse is very brilliant. The protein coat of the anthrax-causing bacteria is right-handed. Because of this little detail, our immune system cannot detect it because its left-handed sensors emphasize time. This means that if this monster tries to eat a human for lunch, it will either be hungry or poisoned due to its odd body chemistry. But what if our earthly reality is the anomaly in the real world? Given that dark matter and energy, which make up 95% of the universe, are invisible to our senses or technology, aliens are most likely there. As a result, because most aliens are invisible, they don't appear to be anything. The Milky Way may contain up to 300 million Earth twins, all of which may be inhabitable for humans due to their contending sterility. What if the other regions across the cosmos, which we view as hostile and arid, are instead teeming with life capable of upending our fundamental assumptions about existence as we know it? All that remained after the formation of stars and planets were a collection of rocks. They can be found in any star system. Asteroids are abundant in resources such as iron and different metals, such as carbon. We surely wouldn't mind taking them for ourselves, but some living space machines make them sooner. According to a new study published on Tuesday in the journal Astrobiology, several space organizations intend to bring the Martian rock to Earth for the first time in the coming decade. And whoever gets to evaluate those vital samples may discover something incredible: evidence of extraterrestrial life. A group of scientists argues that if life evolved on Mars millions of years ago when it was a freshwater oasis, some of those organisms could have weathered the planet's poisonous shift through the millennia, remaining strong while that environment degraded into wasteland we now see. But now comes the surprising part. Because buried species would have had the longest survival times, the researchers predict that buried animal remains may still be beneath the Martian soil. As future missions, such as the ExoMars by Roscosmos and the European Space Agency, prepare to gather soil from beneath the Martian surface, we may soon witness some groundbreaking extraterrestrial proof. One thing is almost certain: any alien life will be symmetrical. Everything that grows, that we are aware of, has symmetry. If you split a tree in half vertically, the branches and roots will look similar. All biological things, even inorganic growth, such as crystals and galaxies, are subject to the same laws. The influences of gravity, the surrounding density, and the energy source would determine the alien's size and shape. Photosynthesis does not promote complicated survival tactics. Thus, aliens that mimic plants are unlikely. Food chasing contributes to a mobile lifestyle. If such life evolved in a dense atmosphere, it is most likely a horizontal species. Most vertical animals would survive in a thinner atmosphere. With the concept of symmetry in mind, it is not implausible that aliens evolved in the same way as humans have, bipedal and upright. 2 legs and 2 arms are more efficient than 4 legs. Self-replicating robots, according to this theory, were initially proposed by American mathematician John von Neumann. These machines can learn to evolve and reproduce themselves and only resemble biological life forms, except for unusual vigor and frightening appetite. Scientists refer to these robots as von Neumann probes. They will be tasked with arriving at a specific place, acquiring whatever resources they can, and then begin replicating for the following generation to travel deeper into space. A tiny piranha robot army might take over the entire Milky Way in around 500,000 years. What if another species has already launched them? In this case, most free-floating asteroids have long since developed into raw materials for the creation of life probes. And if von Neumann extraterrestrial machines are ever discovered, humanity as we know it will come to an end. I don't know about you, but I'm at a loss for how to persuade them that humans are more than just biomass for continual self-replication. If all of this is true, those who have been searching for life in the universe will finally find it. The universe will quickly become far more alive, but at a cost that will make it dangerous, if not catastrophic. According to several prominent astrobiologists, we will either have uncovered compelling evidence for extraterrestrial life, or will have exiled its potential existence to the rapidly expanding outer reaches of the cosmos very soon. By the end of the 2030s, one of many initiatives devoted to the search for extraterrestrial life may have provided these answers. By then, Mars samples will have returned to Earth, possibly carrying hard evidence that the red planet ever harbored life, or still does. Spacecraft will be stationed on Jupiter's Europa and Saturn's Titan to search for life in each moon's deep ocean, or in the case of Titan, on the moon's surface. Furthermore, cutting-edge telescopes in orbit and on Earth should be investigating the atmospheres of potentially habitable exoplanets, orbiting nearby stars to discover if any of them possess a comparable composition of biologically infused gases to our own living Earth. And that brings us to the end of this video. What do you think will happen if we finally find evidence of extraterrestrial life? Let us know in the comment section. Don't forget to like, subscribe, and click on the notification bell to get notified when we post a new video.